So we have the three definitions, and we have atomic number, atomic mass, but we're not going to get into that very much today. And if you see atomic mass on this, I think I've changed all of them, and then we have mass number. So the mass number is not on the periodic table, and you'll learn why. Okay? So let me go through here. The atomic number, we kind of covered that already. The yellow is, can you see the yellow? Yeah, it's not great. I don't know if it's just I'm getting old and I'm wanting to I just can't see that yellow. I guess as a baby, you can see it more colors. It's kind of like your hearing. I kind of like that one. It's kind of like your hearing. There are pitches that I've lost in the last 5 years since working here, and it's nothing, well, that's terrible. It's nothing, it's just what you get as old age. And I protect my hearing quite a bit. But they said as a baby, you can see more colors. That one's good. Okay. Atomic number is the number of protons found in an element. Atoms of the same element have the same number of protons, hence the same atomic number. It is always a whole number. Okay. So, example, go ahead and get your periodic table out too. The atomic number of helium is what? Nope. The atomic for helium. Go ahead and get helium.
Oh, 8?
Nope. Well, helium. Find helium.
Oh, helium. 2?
Uh-huh. Okay. Oxygen has two numbers. Well, on this one, we have 3. We have the 8, 2s2, 2p4, and then the 15.999. What is the atomic number for oxygen?
Is it 8?
So, example, oxygen's atomic number is 8. Therefore, there are 8. It always, always, always is the number of what? Protons. Therefore, there are 8 protons for oxygen. Okay. For a neutral atom, the number of electrons equals the number of protons because there's no charge. So here you could put a quick symbol P plus and 0 E electron, right? And I got to get you guys that quiz. Lowercase p equals with the superscript of positive equals lowercase e superscript of negative. Okay. All right. Okay. The number of protons.
And Reagan's passed.
Okay. Here you go, Reagan. Okay, there you go. We're going to be just up on that top one. I was telling, I'm going to go pause this. Oh, the next one is mass number. I have atomic mass.
Wait, can you go back? I didn't. The number of protons.
The number of protons never change for that given element. It never will change for that given element.
And then it is like a what?
Okay, it's our DNA. It's specific to that.
What's the first one? In a second. The first one is number of electrons.
Thank you. Is the average of a group of atoms, the average mass. Let me go change that. We will get into that. This is on the periodic table. Okay.
So just the average mass.
It's the average mass of a group of atoms of a element. How about that? I like element better, of a specific element. Because we're not talking about not combining nitrogens and oxygens. It's just nitrogens, okay? Or it's measured in atomic mass units, and we'll talk about where that comes from later, but not today. U or AMU. I use AMU. I think it's both interchangeable. Since it is an average, therefore a decimal. And that's where I think I left yesterday. And we're going to do a full few days of just this, okay? We have to do math on this part. Just algebra, not real complicated, but there is math, okay? So as a reminder, if you need to write this side, this reminder down, that's up to you guys, okay? So mass of a proton is 1 AMU, mass of a neutron is 1 AMU, and then the mass of the electron is not important, okay?
Wait, where we prefer it is the length of all
Average. Weighted average is actually the correct term. It's the weighted average, okay? And that's why it's a decimal, but we're going to get into why later on. Somewhere, well, you'll see that this is actually on the periodic table. The next one is not. The next definition. So the 8 on top, I'm going to go back. Are we good here? I'm going to go up 2 slides. The 8 is the what? Atomic number. The 15.999 is the average atomic mass, or you could put atomic mass. I had to spend a lot of time on these notes. They're pretty good. These are actually 2 different sets of notes. Your notes and then this one. And I've used both of them interchangeably. But this is so universal that I can do this, okay? And that's why it's kind of weird on this sheet. All right, so the average atomic mass is on the periodic table. We'll come back to that, but what we're going to focus on is the atomic number and the mass number today. Okay, so down at the bottom you have 2. You have the mass number. This is not on the periodic table. Why? Are you guys there? Okay, so the 8 above is the atomic number. The 15.999 is the atomic mass. And we will use both of those, especially when we get into Stoke, if we get into Stoke. But for right now, we're not going to use that 15.999, and please don't use it until I give you guys directions to do it. And just trust me. Okay? Mass number is the mass of a single atom. It is measured in atomic mass units, U or AMU. I reference it to I use AMU and not U. Okay? It is a single atom, so the data is only obtained from that specific atom, where the previous one was from a specific group of elements. Okay? I think so. I'm just talking to myself, so don't mind me. And I kind of, okay, let me, when you guys get done, I need to see. I'm going to go back behind you guys. I'm going to pause it while you guys were writing. And as we go on this part, okay? All right, so mass number, what is the mass number? What 2 components? What 2 elements? Or 2 subatomic particles? I'm sorry, I was talking, and I asked you guys and then I didn't stop talking. What was it again? Yep, so we have the mass of the protons. And so what math operation are we going to have in between? Yep, we're going to add it. Protons plus neutrons, okay? And when we get done, it's always the unit is AMU. Or you could put U. I'll accept it. That gets a little bit different when we move on, because I can't really weigh the mass of an atom. Not atomic mass, but its mass number. This person had it wrong. Okay, so for example, we have protons plus neutrons. Excuse me. We had carbon, and we have 6 plus 6 equals what? 12. I gotta go. Yep. Look back behind you. So it's 12 AMUs. Okay. Now we got to do math, and we're going to find the number of neutrons. So think about how, using math, how are we going to find the number of neutrons? Okay. Huh? Okay, but how could I have protons minus neutrons and get the mass number? Oh, that's what you just said. Mm-hmm. No electrons. Protons minus neutrons. You might have a negative quantity, and we can't do that. You're on the right path, but you're saying some things wrong. Look at your math operation. We're trying to find neutrons. So, how can I remove protons when they're from themselves? Because if I remove protons, then I make a new element. Okay, find your what you want and what you need. So if I had set 4 protons plus 3 protons, first of all, what element am I dealing with? You got to go get your periodic table out, guys. Because I can't. You got to go find that. If I have 4 protons, what element do I have?